Assalamu alaikum students. Welcome to the 18th lecture of Artificial Intelligence. I hope you are fine and enjoying these video lecture series of Artificial Intelligence. I am Muhammad Umar Farooq, lecturer Computer Sciences, University of Education, Lahore. So we are covering the local search technique. So there are three different types of this search technique: hill climbing, beam search, and genetic algorithm. And we talked about some basic concept of genetic algorithm in our previous lecture. So here are some basic concepts. मैं इसको दोबारा फिर रिवाइज कर लेता हूँ. The genetic algorithm. This algorithm inspired from biological evolution. So we will find the approximate solution instead of finding the exact solution. This is the variant of stochastic beam search because it generates the next population by using the concept of random number, जो कि randomly generate करता है number को, फिर उसके ऊपर random number जो generate हुआ उसको हम अपना क्रॉसओवर पॉइंट कहते हैं. उसको कट करने के बाद हम जो क्रोमोसोम्स होते हैं उसके अंदर चेंज करके नई पॉपुलेशन जनरेट करते हैं. So these are the basic concepts, basic points which you need to understand before going into the detail of the genetic algorithm. So the chromosome, you must know about the chromosome, population, genetic operators. There are two operators, crossover and mutation, fitness value and fitness function. In the same way, we must know about the termination criteria. So मैं इसको दोबारा फिर रिवाइज कर लेता हूँ. Just look at this chromosome. Chromosome is a string of bits is known as chromosome, and each bit is known as gene. For example, there are two numbers 25 and 30. So I will convert these two numbers into binary form. So just इसको binary form के अंदर convert करें. So these ये हमारे पास क्या है? These are the chromosomes. जिस तरह से मैंने कहा कि this is the bit of string of a bits. So ये हमारे पास क्रोमोसोम है. In the same way there are two other chromosomes. ये भी हमारे पास एक एग्जांपल है क्रोमोसोम्स की. The second concept is population. So if there are multiple chromosomes, then these multiple chromosomes will represent a population. So just look at this point, that the population consists of a set of chromosomes, each of which, as we have seen, is made up of genes. So genes के साथ मिले हुए multiple chromosomes को population कहते हैं. The size of the population should be determined in advance. The population size remain constant from one generation to next generation, but it may we can change the size of population for our problems. हम इसको change भी कर सकते हैं. So the third point is the crossover and mutation. We talked about this concept in our previous lecture. So just यहाँ पे उसका overview कर लेते हैं, क्योंकि हमने आज genetic algorithm की example करनी है. तो उस example को समझने से पहले हमें क्या करना चाहिए, एक दफ़ा इसको revise कर लेते हैं. So the crossover is a genetic operator. So this is a binary operator. The algorithm for this operator is select a random crossover point, break each chromosome into two parts, splitting at crossover point. So we will generate a random number, और उस नंबर के ऊपर हम क्या कर लेंगे, कट कर देंगे, उसको ब्रेक कर देंगे क्रोमोसोम को. Then we will recombine the broken chromosome by combining the front of one with the back of the other, and vice versa to reproduce a new generation. So we will generate two new chromosomes by using the crossover operators. So just look at this point. I generate a random number which is between the 6th and 7th gene. So I just split these two genes into two parts. I combine the first part of this gene with the second part of this gene. So ये हमारे पास क्या है कि I will generate I generated these two new chromosomes. So this is our new population and this is our old population. So the second operator is mutation. Mutation is just like a NOT operator. So mutation is a unary operator. So just it requires only one chromosome. ये हमारे पास crossover जो है वो दो chromosome required करता है, लेकिन mutation क्या है, उसको एक chromosome चाहिए. So it will reverse the value of a bit or gene in a chromosome. So it is a random number. I will again generate the random number or at that location, जो कि मेरे पास रैंडम नंबर जनरेट हुआ वहाँ पे जाके क्या करूँगा मैं, जस्ट आई रिवर्स दी बिट। अगर इफ मेरे पास जो है वो 0 है तो आई विल पुट 1 ओवर हेयर, अगर मेरे पास यहाँ पे 1 होता तो यहाँ पे मैं 0 कर देता। So the next concept is a fitness function, the fitness function that evaluates the chromosome by checking the error of problem. So we will generate a function जो कि हम क्या करेंगे, एक जो क्रोमोसोम बनाते हैं उसके ऊपर हम देखेंगे कि हमारी प्रॉब्लम जो है वो कितना एरर जनरेट करती है। सो वो जो एरर होगा वो कौन डिसाइड करेगा, वो हमारा फिटनेस फंक्शन डिसाइड करेगा कि इतना एरर आया। So the error function we will minimize the sum of squared error for our problems. So sum of squared error. So in today's lecture I will discuss a polynomial fitting problem. मैं इसके ऊपर एक लाइन फिट करूंगा एक पॉइंट के ऊपर, then I will make a error function which will be the sum of squared error. मोस्टली जब न्यूरल नेटवर्क की हम बात करेंगे वहाँ पे भी हम सम स्क्वायर्ड एरर बनाएंगे। सो सम ऑफ स्क्वायर्ड एरर आई विल मिनिमाइज दिस एरर फंक्शन। सो मोस्टली हम क्या करते हैं, इसी फंक्शन को बना के उसको मिनिमाइज हम करने की कोशिश करते हैं। So the next concept is termination criteria. So there are two ways to terminate our algorithm. First is we will put the limit on our number of generations. After that I will terminate that our algorithm after creating the number of generations जितनी हमें required है उस limit को जैसे हम achieve करते हैं। So वहाँ तक जो भी best solution होता है वो हमें return हो जाता है, हम ले लेते हैं उससे। So the second point to terminate this algorithm is when we achieve the highest fitness level, or we can say that the fitness function, fitness level, or we can say that when we achieve the minimum sum of squared error in the population has reached at a particular values, जो कि हमें सबसे कम जहाँ पे वैल्यू आती है वहाँ पे टर्मिनेट कर देगा। So the concept is that the particular value हम इसको टर्मिनेट करेंगे जहाँ पे particular value आती है। So that's why this algorithm is approximate algorithm. It is not going towards the error at 0 level. So ये क्या करता है, जो भी minimum उसको मिलता है उसको वहाँ पे terminate कर देता है। So just look at the genetic algorithm. First, initially we will generate a random population which consists of the number of chromosomes. So initially क्योंकि हमारा जो पहला स्टेप है वो क्या है कि फर्स्ट जनरेशन के टाइम हम क्या करते हैं, रैंडम पॉपुलेशन जनरेट करते हैं। So next step is if the termination criteria are satisfied, so we will stop this algorithm. Otherwise we will move towards the step 3. So at this step we will determine the fitness of each chromosome. So then apply the crossover and mutation to select we will apply the mutation or crossover to selected chromosome. तो यहाँ पे जो हम क्या करते हैं, जो भी हमारे पास फिटनेस जिसकी अच्छी आई होती है हम उसको सिलेक्ट करते हैं, उसके ऊपर हम क्रॉस ओवर और म्यूटेशन लगाते हैं। फ्रॉम द करंट पॉपुलेशन टू जनरेट न्यू पॉपुलेशन ऑफ द क्रोमोसोम्स इन द सेम वे, जो कि हमारे पास नेक्स्ट जनरेशन होती है, देन वी विल मूव टुवर्ड्स द स्टेप 2। तो सो द स्टेप्स 2, व्हाट इज द स्टेप 2? इफ द टर्मिनेशन क्राइटेरिया आर satisfied we will stop, otherwise we will check the fitness value or error function, error value, then we will apply crossover or mutation, move towards the step 2। so इसी तरह से हमारा ये लूप जो है वो ये इस तरह से चलता रहता है। So just look at this problem, the polynomial fitting problem. Suppose you have points xy. There are 2 points 1, 5 and 3, 9. So we have 2 data points. I will fit the 1 degree polynomial through these data points. So what is the 1 degree polynomial? हमारे पास 1 degree polynomial क्या कौन सा होता है? So 1 degree polynomial is a line. The equation of line is y is equal to mx plus c. So मेरे पास ये 2 points हैं. I will fit the line on these 2 points. So to fit this line, I must know about the equation of the line. so which is the y is equal to mx plus c. So to find the line which is passing through these two data points, we find the value of m and c. So वो कौन सी m और c की वैल्यूज हैं जिनके होते हुए हमारे पास जो है वो ये इक्वेशन सेटिस्फाई होती है इन डेटा पॉइंट्स के होते हुए. So to find the line which is passing through these two points, I will find the value of m and c. So I will find these two values by using the genetic algorithm. So just look at the next slide. So first concept is population. Just look at this algorithm. So initially generate a random population of chromosomes. So first step is to create the random population. So I created a random population. So population for unknown parameters. So there are two pairs of m and c which are 2, 7, 1, 3. So then I will check the error function or error value for this problem. So मैंने यहाँ पे आप ये भी एक सोच रहे होंगे कि मेरे पास जो क्रोमोसोम्स होते हैं सो वो हमारे पास क्या है कि उसके अंदर जीन्स की वैल्यू होती है जो कि बिट ऑफ स्ट्रिंग ऑफ बिट्स है, बट the chromosome of M and C is 2 and 7. So we can represent these values in the form of chromosome. Just look at this point, this slide. I just convert these two values into binary. So this is our representation for our chromosomes. So ये हमारे पास क्या बन गया 0 1 0 1 1 1. So this is 2 and 7 1 and 3. So just I created the random population for this problem for these unknown parameters. So the next concept is error function. So for our problem the error function is equal to sum of squared error. So just look at this equation that the sum of squared error is equal to summation p1 to pn. So p1 pn mean the number of points. If there are 3 points, so p1 and p1 pn will become the p3. So the actual value ypn minus predicted value which we will represent the predict value by y prime. So just I take the difference, mean के जो उसका difference है वो क्या करेगा, that will represent the error. Then I will take the square जो कि eliminate करेगा the impact of this sign, negative sign. So क्योंकि बाज़ दफ़ा हमारे पास नेगेटिव वैल्यू आ जाती है तो एक नेगेटिव आ जाए एक पॉजिटिव आ जाए. फॉर एग्जांपल the error function, the error value for point 1 is positive and the error value for point 2 is negative. So जब हम उसको दोनों को ऐड करेंगे तो उनका impact ख़त्म हो जाएगा. तो to avoid that impact, the negative sign impact, I'm taking the square for this error. So then I am adding the error value, the squared error value for all data points. So that's why I'm calling this function as a sum of squared error. So मैं इसको squared error function इस वजह से कह रहा हूँ. So now I will compute this error function, or I will compute the badness for our this chromosomes. So initially the first chromosomes are for for M and C is 2 and 7. I will represent the value of this chromosomes as a 0 1 0 and 1 1 1. So just put these two values in this equation. So y prime mean predicted y is equal to 2x plus 7. So now I will predict the value of y for these two data points. So just look at the next slide, जो कि जिसके अंदर मैं क्या करूँगा कि इसको प्रिडिक्ट करूँगा y प्राइम को. So for these two data points, initially for 1 5, so just I put the value of 1 over here and the predicted y is 9. In the same way, the predicted value for this data point, I will put the 3 value in this equation. So the predicted y is equal to 13. So मेरे पास predicted value क्या बनी है 13 बनी है, but the actual value for this data point is 5. but the actual value for this data point 3 9, the actual value is 9 but our predicted value is 13. So in m और c के होते हुए फॉर दी m और c क्या है हमारे पास 2, इन दोनों के होते हुए मेरे पास प्रिडिक्टेड y जो है वो 9 आ रहा है इस डेटा पॉइंट के लिए और इसके लिए 13 आ रहा है. So just look at the next slide. So I am computing the error for this chromosome 27. I will compute the sum of squared error, so which is equal to the 32. So मेरे पास पहला पॉइंट क्या था, मेरे पास पहला पॉइंट था एक्चुअल जो y है वो 5 है but the predicted is 9. In the same way for second data point, the actual y is 9 but the predicted value of y is 13. So just I put these two values over here. So the sum of squared error for this chromosome, for these chromosomes of M and C, which are the 2 and 7, is 32. So for our next pair of M and C, which are randomly initialized, the value of M and C is 1 and 7. Just I put these two values in this equation. The y prime, the predicted y is equal to x plus 3. So 1 जो कि मैं इसको 1 को हम नहीं भी लिखते इस तरह से. So the value of y prime is equal to x plus 3. So I will compute the error function for this M and C. So just look at this slide that I will put these values of x in this equation. So initially the x is 1, so I put this value over here. The y prime, the predicted y is equal to 4, but the actual value of y is 5. So the actual value of y is 9 for this point, but the predicted value of y is 6 for this data point. So the error is 5 minus 9 square, so 9 minus 6 square. So the sum of squared error हमारे पास क्या आता है? Just look at the next slide. The sum of squared error for these two data points by using the value of M and C is 1 and 3. See, the sum of squared error is equal to 10. So just look at this slide, the error function, the error sum of squared error for chromosomes 2 and 7 is 32. The error function, the error value for M and C, which are the 1 and 3, is equal to 10. So according to our algorithm, I just created a random population. Then I calculate the error functions for these chromosomes. So then next step क्या है मेरे पास? Then जो उसका according to algorithm, I will generate a random point, crossover का हो या mutation का हो. Then I apply the crossover and mutation on the selected chromosomes. So I will select these chromosomes which have the lowest error. So I will select 1 3 chromosome जो कि मैं इसको क्या करूँगा next population को generate करने के लिए use करूँगा. क्यों? Because the error value for this chromosome is क्या है कि मेरे पास 10 है जो कि minimum है इससे, जो कि अच्छा chromosomes consider होता है for our problem. So just look at this slide that the error function 2 7 is greater, so skip this chromosomes. So I will apply the mutation on these chromosomes. So just I apply the mutation for at our first chromosome at this location. Just I reverse the value of 0 towards the 1. So मैंने इसको reverse कर दिया. So the new chromosomes, the new population is 3,3. So now I will calculate the error function, the error value for 3,3, which is our new chromosome, and 1 3 जो कि हमने पहले इसको कैलकुलेट कर लिया हुआ है. So क्योंकि हमने ये बात की थी कि the population size will be constant, so the population मेरे पास क्या है कि ये 2 pairs होने चाहिए. So I have 2 pairs. So मैंने इसको skip कर दी जो जिसका error function जो था वो हमारे पास error की वैल्यू ज़्यादा आ रही है. So the error function, the error value for m and c, which is equal to 1 and 3, is 10. So I will compute the badness for 3, 3. So the new equation is will be y prime is equal to 3x plus 3. So I will put the value of x from these data points. So just look at the next slide. So for this data point 1, 5, I will put the value of x over here. So which is y prime is equal to 6. The error is equal to 5 minus 6 square is equal to 1. So actual value is 5, but the predicted value is 6. So this is our error value. So in the same way for this data point, I will compute the error value. So the predicted value is 12. मैंने क्या किया, मैंने 3 की वैल्यू इस इक्वेशन के अंदर पुट की है. सो द प्रेडिक्टेड वैल्यू इज 12. द एरर फंक्शन, the error value for this data point is equal to 9. But the sum of squared error, I will add up all of these errors. So मैं इसको क्या करता हूँ, मेरे पास sum of squared error मैं calculate करता हूँ. So the sum of squared error for this population, for this new chromosomes, which is equal to 3, so the error function, the sum of squared error is equal to 10. So हमने क्या किया अभी, I generated a new population by applying the mutation for this chromosomes, for these chromosomes, जो कि मैंने 1 के ऊपर अप्लाई किया था. तो दोनों के लिए मेरे पास क्या है कि एक ही वैल्यू आ रही है. So then I will pick, मैं किसको पिक करूँगा, जस्ट गेस करें. So I will pick the second generation. So मेरे पास ये पुरानी जनरेशन है, मैं नई जनरेशन को यूज़ करूँगा. So the error is same, so I will keep 3, 3, which is updated chromosomes. Then I will again apply the mutation. So mutation क्या होता है, I will generate a random number. At that location, I just reverse the bit. If the value of bit is 1, then I will reverse the value from 1 to 0. In the same way, if there is 0, so मैं क्या कर दूंगा, उसको reverse कर दूंगा 1 के ऊपर. So 3, 3 will become 2, 3. So now I will calculate the error for 3, 3 and 2, 3. The 2, 3 is our updated or new generation. So just look at this slide. The error for M and C is equal to which are equal to 3, 3 is 10. The error value is 10. So now I will compute the badness for 2, 3. So the chromosomes are 0, 1, 0, 1, 0, 1, 1. So I just put these two values in this equation. So the predicted y will become the mx plus c. Now m is equal to 2 and c is equal to 3. Y prime is equal to 2x plus 3. So now I will predict the value of y for these data points. So just look at the next slide. For this data point, I will put the value of 1 over here. So 1 is here. So मैंने क्या किया, मैंने just उसकी 1 की value put की है. तो y prime is equal to 5. So the error, so this is our interesting example, interesting problem कि हमारे पास interesting point कि मेरे पास क्या है कि error will become is equal to 0. So in the same way for this data point, which is equal to 3, 9, so the predicted y is equal to 9, which is equal to the actual 9. So the error value is 0. In the same way, the sum of squared error is also 0. So हमारे पास क्या है कि sum of squared error क्या है, मेरे पास ये भी 0 आ गया for m and c, which is equal to 2, 3. So I found the solution for to fit the line between these two data points. So the value of m and c is equal to 2, 3. So the equation of line is y is equal to 2x plus 3 for the data points x, y, which so for these two data points मेरे पास क्या है कि equation of line क्या है, वो ये बन जाती है. So the value of m is equal to 2, value of c is equal to 3. So in our this video lecture, we fit the polynomial in these two data points. So we have two data points, that's why I am fitting the 1 degree polynomial, which is equal to the line. So I just found the solution, the equation of line for these two data points, which is equal to y is equal to 2x plus 3. So I hope you enjoy this video lecture. So if you have any question, you can send me an email. Inshallah, I will try my best to answer your question. Thank you for watching this video. Allah Hafiz.